Hello and welcome to the Avid Workflows with eMAM and NLT webinar. My name is Chuck Bulow. I'm the VP of Business Development here at eMAM. Joining us today is Anup Thomas, Director of Technologies at eMAM, and Jim McCain, President of NL Technologies. In today's webinar, we'll be discussing the new integration with NLT Near Archive and Media Transcoder platform, creating a seamless media and metadata workflow with Avid Interplay in Avid iNews. eMAM has entered into a strategic partnership with NL Technologies to advance and enhance the Avid workflows in eMAM. eMAM is a media asset management software that helps centralize, organize, share, and distribute all types of media and metadata. This new integration helps streamline and sharing of media and metadata between eMAM and the Avid platform. Anup Thomas will now talk about the integration in more detail.
Thank you, Chuck. With the integrated system, we can index media and metadata from Interplay into eMAM. Once the media is indexed, users can browse the Avid OP Atom media directly from the eMAM interface and trigger the wrap or transcode options from the eMAM user interface. eMAM can also share and distribute the media to S3 buckets, network locations, and other systems like Premiere and Resolve. Another workflow is to ingest or check in the non-Avid media to Interplay. To transfer media and metadata from the Avid environment, we use NLT Near Archive as the middleware. NLT is capable of scanning stories from iNews and processing the associated media, not just interfacing with Interplay. It can also interface with iNews. Here is a high-level diagram showing the flow. eMAM receives the metadata XML, the original media, H.264 MP4 proxies, and a thumbnail from NLT archive. Then eMAM creates the asset based on the information provided in the XML. In the reverse workflow, eMAM hand over the media to the NLT media transcoder. That is a separate product from NLT, which then check in the media to Interplay. If the asset in eMAM originated from the Avid environment, we retain the MOB ID in the system. For non-Avid media like camera, raw, ProRes, etc., this process involves transcoding to create MX of OP Atom media. Now we will demo the product features from this lab setup. We have eMAM running from an EC2 instance in Mumbai and the eMAM app node running from a physical server in the NLT lab in Boston. Additionally, we have Interplay, iNews, Avid storage, NLT media transcoder, and eMAM storage, which is a NAS, running from the Boston office. I will now invite Jim to demonstrate NLT Near Archive and media transcoder and their integration with Avid Interplay, iNews, and Media Central. After that, I will showcase the eMAM interface. Jim, the floor is yours.
Okay, can you see the eMAM screen?
Yes, we can.
So this is Interplay Access. So this is an Avid tool. You may or may not be familiar with it. We have some clips in here, and we can just select a couple clips and right click, and we should have the plugin. So this is an extension to the right click menu in the Avid tools. We use the Avid tools for the interface to the user. So the customer is already familiar with these tools, and to access our archive, we simply enhance the right click to allow that. So there are two entries, the services and the management console. So I'm going to start with the services. What it does is it says, okay, you've selected two assets and you want to go to a target server. So we're going to select this one to begin with. Yeah, let's do that one. So this stores the content, or we can restore the content. So if these were offline, we could restore from the archive and bring the content back online. In this case, we're going to store it. So I'll just put a little comment down here and we hit OK. So this should send a job to the nearchive engine that's running, and it would be processed and retrieved. Now the management is a web interface, and the management interface should show you the job interfaces. And I got to get to a proceed unsafe state. So these are the jobs on this particular server that were submitted. And you can see that this was a restore operation, and the master clip was partially restored and the subclip was restored. So this is a partial file restore operation. But basically, when you submit a job, the nearchive engine picks it up and performs the operation, whether it's either going to store content to the external storage via NAS or something like that, or restore content from the external storage back into Interplay. So this is kind of the job interface. So after you submit a job to it, this is where you would see the status. So once the content is written there, now we had some demo clips on here on the E drive, I believe. So these files are written to a folder structure, and the folder structure is what Anup has picked up, and he's picked up the data portions, the MXF files, and the XML files. And so this is the XML file that you're importing, and it contains all of the metadata that we've taken out of Interplay. So this is all the media files, the formats, their locations, all the metadata that describes the asset, all of the um, durations, creation dates, basically everything that's in Interplay, the associations to sequences, all of that is in this XML file. So Noop has taken this and imported it into eMAM that can describe that asset. Basically read the OP atoms, and I think are making an OP1A, and maybe using this MP4 file, which is a proxy video of the asset, and putting that into eMAM. So this is the system configurations, and these are pretty much static configurations that a system manager would set up. But one of the options is integration into iNews. And the iNews server has a portal that uses the iNews web services, which is a kind of a third-party definition for how to access it. And so those web services are running on this computer on this particular port, and we can test that, and we can talk to the web services. And then to talk to the iNews server itself, we pass the host name through the web services. So there's like a double hop going on here. So when we test this integration, okay, it's able to talk to the iNews, it's got its IP back, and everything passed. So what we've done is once the configuration is set up that you can talk to iNews, you can actually go out here and look at all of the iNews folders and queues. So here we have wires. I think I've been playing around with the show, I believe. And I've made a folder called eMAM demo. And here are two different queues with, I've been trying to get some stories in them. But we can select this whole folder, or I've already selected the 5 o'clock and the 11 o'clock um, rundown queues. So you can select them individually, or you can select um, the whole folder's worth of rundown queues. And you can go down here and enable the different metadata that's going to come out of iNews as well. So we can import the story ID, the slug, the date, the story body is important. So all of the content that's put into iNews as far as the story description, we can pull that out and archive that as well. So once this is all configured, um, you set up different schedules. So I can say, okay, at 7 p.m. I want to, on a Sunday or maybe every day I want to do this. I set up a time where I want to query the iNews server. So anything that's changed since the last time this is run, and we can set up another query for midnight if we wanted to. So this query would run at midnight, this would run at 7 p.m. And it would take any changes that were made in iNews from the last time it ran based on the folders and queues that you have selected and the metadata that you want to pull out. So again, this is set up pretty statically. Once you have the shows and the queues defined and the metadata defined with the schedule, the nearchive server just automatically goes out based on that schedule and queries iNews, pulls the content back. Well, basically it creates a job, just like we manually selected a couple of assets and said, send these to the archive. It would go out and query iNews and create a job that would just execute. So that would store all of the content that it found that had changed since the last time. And so that's kind of the definition. Um, the user would use the iNews client. It's already running. So iNews client, the user would use the iNews client. For example, these are the stories that I've been working on. And so a customer would use this interface to build the stories that then we would archive once they ran. And so that's kind of what's going on with iNews. We have another integration with Media Central. I showed you Interplay Access, and I've showed you using Chrome as just a browser to access the status of what's going on with the archive application. But we've also integrated into Media Central. And this integration provides more of an integrated approach to managing all of that put together. So we can navigate to catalogs, go back to Emory. I can right click and go to the nearchive services. Again, this is all integrated in here. So I could send this to different servers. But the web interface is up here. So we can go and let's pick Red NC because the other one's not working. We can see an integrated approach. So everything is presented to the user right here. So I can have up browsing with catalogs, or I can look at my different jobs and see what's going on. And so that's the integration with Media Central. We've again implemented that right click with the browsing feature, and we've integrated an application that lets us query the web server that's running on the nearchive server to say what's going on. I've submitted some assets to be archived or restored. This is the progress of what's going on. Were there any errors? Is it still right into tape? It'll show you all that information. So again, all these settings are kind of system management level configurations. The user would not be in any of this. This is where the integration into Avid Web Services, and then this is the Avid Storage. So the host name of the Avid Storage, the workspace. So this is basically defining a place where we can restore content if the original workspace no longer exists. So think of this as an archive, and workspace names in the Avid environment can change based upon system managers changing roles or whatever. Maybe they've got a new piece of hardware they brought in and they've developed a different workspace name. Well, when we archive content, we save the original workspace that it came from. So we always try to restore it exactly where it came from. But if that workspace is not available, this definition provides a current alternate location where it would be restored to if the original no longer existed. Or you notice there's a restore override button. In that case, any restores, we would use these paths to restore the high res or proxy to a given workspace. That's the integration here.
And in this case, instead of sending the file to LTO, the eArchive is placing the files in that E drive. That can be the NAS and or any other shared storage location. So we built the integration at that level. So we look for that location. It's configured here periodically. And if there is a change, if there is a new XML present, we take that one. And then at that point, we are actually not doing any transcoding or anything. We just index the media, like we index the OP atom media in eMAM. And then we use that proxy provided by, again, there is a proxy file and the thumbnail provided by eArchive. So we load that proxy into eMAM, and that proxy goes to the cloud. And from there, you can directly access that location, that eArchive location from the browse interface, eMAM browse interface, and then you can trigger the delivery. So if you do a trigger the delivery, at that time, we do a wrap job and wrap it as OP1A and send it to the other systems, like external systems other than Avid. Then the opposite workflow, suppose if there is a GoPro footages or files are coming from other system like ENBS or Octopus or whatever other news systems or other sources, we send that media to the media transcoder. That's a separate product. And then the media transcoder can check in that to the Avid environment.
So if we're just going to receive an OP1A type file, what we have is a watch folder that was designed to just read OP1A media and rewrap it, which happens very, very fast. So we have a watch folder that we've defined on either a network share or a local drive. And then we've defined where we want the content to go on the Avid side. So the OP atoms are placed in this folder. And then a check-in folder where we've defined the where the media is going to be checked into. And if we want to change that folder, we can just select a different folder. So all of this is coming right out of the Interplay database in real time. So we can select a different target. We can create a new folder for a target. But this is the check-in folder. This is where the storage is defined for the OP atom. And this is the watch folder where the OP1As would be dropped. And we also have another watch folder where we can take GoPro or MP4 files or what have you. It's a very similar type of definition, except that it has the capability to not only watch for a folder, but to transcode it to a specific target. So if it comes in H.264 in an MTS or MP4 file, we can say, okay, well, the house format is XDCAM 50. And we're going to create XDCAM 50 media from that original source and put it in the respective check-in and storage locations on the Avid storage LAN. So there's a couple of different ones that we have defined here. We have the capability to define multiple workflow engines to have different watch folders. So you could have one for sports that went into a sports ingest. You could have one for, dailies. You could have one for news. You could basically design as many of these as you wanted to have.
Okay, so then let me take out and show the view from the eMAM side. Give me 1 second. Okay, here is the eMAM director interface. In the browse widget, there are options available to browse different storage types. As we are indexing the media from the Avid environment, the storage will be listed under the source storage. When I go to NLT, this is something I am browsing NR storage. I can go to assets, maybe 400, and then I can see an asset inside that location. So in this case, I'm previewing the H.264 MP4 proxy video that exists in an S3 bucket in Mumbai, and also I am getting the thumbnail from the NLT environment, but the original media that exists in this NAS location in Boston. Let me connect to the team viewer. So now I'm in the team viewer connected to the app node in Boston. So let me go to the this location, and so again this is that NAS. So I'm just browsing that NAS storage. Assets 400, and yeah, these location, the files are like this one. There are multiple MX of files, XML files, and so on. But we are mainly scanning this folder and indexing that in the eMAM system. So if you look at this XML, there is the name of the file coming in, the interplay source path, and all other informations are there, locators and all other information. We are taking from this XML, like modified date and the master clip details, the MOB ID and all those things. We are taking from this XML and showing that in the eMAM system. So if you look at the metadata, so there is basic metadata. This whole information is coming from that XML. There are embedded metadata. As you can see, this is an OP atom MXF file exists in that location, and then there is also Avid related metadata like MOB ID and source MOB ID and so on, and also the file path. The locators are coming from that system, from Interplay. And now this proxy is connecting to that original media that exists in the storage in Boston. And another view, let me quickly go to the again now I'm in the app node in Boston. So let me just sign into the Media Central. So again there is an option to sign into the Media Central or the Interplay. So you can see from here. So there is catalogs, gym, demo, all those things are there, right? The XDCAM 1080. So all these details are available here, and of course you can browse the same thing through here, and that information is available here too. So now if you look at eMAM, we have the same structure. So if you let me just maybe go to the search filter. Let me close the project. Categories, catalogs, gym. See that entire structure is available in eMAM. So if you click on here, so I can see the same view here too. Like so there is a again I can adjust the sort option and all those things here, and that's the identical view what you can see it in the Interplay. So if you do a side-to-side comparison, so this is very identical. So that means we are indexing all the media, and in this case both Interplay is pointing to the media in Boston, and what I am seeing in eMAM interface is just a proxy that is also pointing to the media in Boston. So now if I need to trigger a delivery workflow, I can change my workspace here. So I can select maybe one of these files from here. Okay, let me go to one of these files from this location. and then I can just drag and drop that into my delivery. And so then I have multiple options, like either I can wrap everything to an OP1A, like consolidate that OP atom into OP1A, or I can transcode and create that XDCAM50 or some kind of a destination format, and I'm going to add that to the delivery queue. So in this case, if I go to my dashboard, so there is one item queued and that is processing. So now the app node in Boston is going to pick up that job, and it's going to deliver that file to this folder, the delivery. As you can see, the file is appeared here, and it is creating new files. And so that file, if you look at the media info, this one is a wrapped file. It's a consolidated OP1A MXF with multiple audio tracks. Like there is a audio track 1, audio track 2, 3, 4, 5, 6, 7, 8, and so on. So that is the consolidated file. So in this way, we can take an Avid OP atom file and consolidate or transcode and push that to other locations. So this is again a distributed hybrid architecture. I'm managing that delivery workflow from a web user interface. The actual job is carried out by the app node running here. That app node is, again, we got a lot of background services for managing the ingest, the cloud connectors, the delivery manager and archive manager, and there are task manager and so on. So then the reverse workflow, suppose if I have the eMAM system and I have the files maybe in an S3 bucket or other location. These are the non-Avid media. So these files may be coming from camera or GoPro or some other sources. Let me go back to the cloud storage again. Okay. So now if I need to send this media to Interplay, what I should do? So I can drag and drop the similar. It's a similar workflow, but earlier I delivered a media from the Interplay to the other network storage location. In this case, I'm delivering a media that exists in S3 to the Interplay, and so in this case, I'm going to trigger the delivery. Okay, before triggering the delivery, let me just show you what is going to happen behind the scenes. So the app node is going to pick up that job, and then it hand over that file to the media transcoder. So the media transcoder is again an NLT product, and in the media transcoder, it is looking for the media coming to this location, and then it is creating an XDCAM50 OP atom, and then it is check-in to the Interplay, to the eMAM ingest folder. So that is the overall workflow, which I'm going to trigger it from the eMAM system. So from the eMAM, I'm going to click on deliver, and in this case, I'm going to select the option send to Interplay to trigger that workflow. And now the job is added. If you go to the dashboard, you can track that job from the eMAM dashboard. And also, if you come here, that job is going to appear here in the media transcoder. And then eventually, so that the job is appeared here, the progress is 0%. It's progressing now. And now if you go to the media central and go to the incoming media and eMAM ingest, that's already showing up here, but now there is no media. And also if you look at here in the incoming media, so the file now it's showing no head frame, but once the process is completed, then media will be completely checked in into the Avid environment. From there it can go to iNews or like whatever kind of destination within the Avid environment. So the workflow is bi-directional. So we can index the media from the Interplay environment in eMAM, and then connect all other workflow that exist in the eMAM system. So if you look at all the different widgets and everything, so we can connect all these workflows, and also we can bring the media from the non-Avid environment to the Interplay environment. This is all workflow handled through two different products from NLT. One is the eArchive and another one is the media transcoder. So there is a round trip workflow between both the systems. Yeah, there is a lot of other things to show. Open for QA, and so let me know if there is any questions. Please use the question section, and we will answer those. So any questions?
Yeah, if you have any questions, just go ahead and add them to the questionnaire in the GoToWebinar. If not, Anoop, do you want to kind of explain the components of the system? So you need a NLT system plus the eMAM server as well?
Yes, give me 1 second. Okay, I am sharing another screen. Can you see it?
Yes.
Okay, so yeah, as I explained earlier, the setup is like this one. Again, this is a lab setup, and so we have one app node that is configured with different software components that is running from the Boston office, NLT lab in Boston, and then we have another EC2 instance running with all the gateway director, all those user interfaces and the API gateways and other things. And then when it comes to the storage configuration, so this configuration, we have like a NAS storage in Boston that is configured here. That storage is kind of binded to the app node in Boston. That's how we kind of configure a distributed hybrid architecture. So we can have the storage in different locations, and then the app node can connect to that. And here the special thing is that this the storage location is the destination for the NLT eArchive, and this is where the NLT eArchive will drop the metadata XML and the media coming from Interplay. So that means the eArchive is acting as a middleware connecting the Interplay environment with eMAM, and then we also have the S3 cache in Mumbai. So that is where we kind of the synchronize all the proxies and thumbnails and so on. And I think the on-prem storage in Boston, that is also configured to push the proxies and everything to the cloud. And again, we have various options here. It can be Microsoft Azure, IBM Cloud, NetApp, Google Cloud Storage, and also it can be any other type of storage like Wasabi or Backblaze B2 and so on. And then another configuration we have is the ingest profile configuration. So there we are using NetX Convert for the rewrap job, and also we use the NLT media transcoder to check in the media to the Interplay environment. And also there are options to plug in various transcoders. We can support Telestream and Adobe Media Encoder Harmonic and so on and so on. And then another and then also we can configure multiple delivery profiles. So these are the options which I have showed it in the demo. Send to interplay, that is just a configuration. That means if I have a camera raw material or something, I will be sending a duplicate delivery to the MB4 MOV top folder. This folder is configured inside the NLT media transcoder, and then they do the transcoding, create a HDCAM50 OP atom, and then check in the media to the Avid interplay environment. And also this is offloaded to the app node in Boston. That's how we can offload the job to different servers sitting in different places. And then when it comes to archive, there are various options. So this is a kind of a value addition we are bringing into the interplay environment. So once the media is indexed in eMAM, we can pretty much send the media to any of these destinations, send data or DAC Alto or Glacier, Quantum. There are various options there. So again, these all integrations we have built over 16 years. So the ecosystem is really large, and then we can send the media to this location. Then also there is the artificial intelligence configuration. So we can use recognition and transcription, and so there are various options here: Microsoft, Google Vision, and then Google speech to text, IBM Watson, and all these things you can combine to that workflows. Again, there is a workflow module. You can also configure the workflows here. Based on the event, you can set conditions, and you can trigger different actions. So these all things we can do it in the eMAM system. So again, this is a backend configuration. So this is just one-time configurations. And Jim, do you want to mention anything from the near archive or media transcoder side which we have not touched upon from a configuration standpoint of view?
Yeah, so the near archive has to run on a server class machine. That's generally where the storage is, but we could use alternate storage via NAS. And then the transcoder would run on basically any Windows box. It should have probably minimum of 8 cores. And the other thing to note is they can be on the same box. So we could have a single Windows server running Windows 2022, hosting both the near archive, potentially the storage, and the transcoder, all running on that one Windows implementation. Probably to just add one more point, that Windows server instance can be a VM running on an internal VMware structure. So we've used some other hypervisors, but primarily we test with VMware.
Great. Okay, so it seems like the system's pretty flexible as far as like where you can store things and manage media and manage the eMAM system, you know, as well as the NLT system. So that's great. So I don't think we have any more questions. If you do have any more questions, please feel free to contact us, emamsolutions.com. And Jim, I believe it's nltek.com? Or
nltek.com.
All right. Appreciate the time today. And folks, if you have any questions, just give us a call or contact us via our website. And appreciate the time. And this recording will be available as well online, so we'll make that available to you as well. So, all right. I appreciate it, guys, and have a good day.
Okay, thanks. Thanks, everyone. Have a good one.